All right, we are going to look at two types of prisms that are a little bit different than the plane figures. We're going to be looking at pyramids and cones. Same concept. Our total area is going to be equal to the lateral area, but now once you are talking about a pyramid or a cone, there's only going to be one base area rather than two. So we're still going to break it into two different things. We're going to have a lateral area and then a base area. The thing about these two figures, both of the lateral areas are going to be triangles. And so the area of a triangle, 1/2 base times the height, it's going to be the same for both. So then looking at this in a little closer detail, get this off. Let's look at the pyramid first. We're going to look at a square pyramid, which means its base is going to be a pyramid. Okay, so here's our square pyramid. Now you can see that the base area is this square. So we got that square that we're dealing with, but then it all comes to a point, and that point is the vertex of this isosceles triangle. Now to find the area of a triangle, 1/2 base times the height. However, we have two different types of heights here. We have one height right here that is the actual height of this lateral face or the triangle. That height is referred to as the slant height because it's kind of slanted for the pyramid. And that's going to be represented by a cursive L. And then, of course, our regular height is going to be the actual height of the pyramid. Now, if you look at this carefully, what we actually have is a figure down there. And then if you were to draw in the apothem, what we have is a right triangle on the inside. And because we know that's an isosceles triangle, this is an altitude, so it also makes a right triangle. So we have two right triangles, and if you look at it, this right here, this height right here, is a leg to this surface triangle, but it's the hypotenuse to the triangle on the inside. So you're going to have some contradictory sides. They're going to mean different things. All right, so let's pull all this stuff away. It'll probably just be easier if I go to a different page. All right, so then we have this pyramid. We've got the square base. So the capital B is still going to be equal to whatever the figure is, so that's S squared. And then the face, the lateral area, is going to be the four triangles. So we're going to take these four triangles, like the nets that we did last week, and what we have is that each one of these sides corresponds to a side that we already have. So this length right here, the entire length, is actually the perimeter of the base figure. Okay, so let's say that we said that our base figure had a 6 all the way around. So then the perimeter would be 24. Well, then we need the slant height, because that height right there is going to be the exact same height on each one of these things. So that's going to be our L, our slant height. And if we drew all this stuff in here, we could see that that would be a 3. We're going to say that the slant height here is going to be 5, just for argument's sake. All right, so to find the total surface area, we're going to take 6 times 6, So our base area is going to be 6 squared, or 36. And our lateral area is a triangle, so it's 1/2 base times the height. However, we're going to eliminate base. We're going to do all 4 of them at the same time. So then we're going to put the perimeter in there times the slant height. And that's going to give us our lateral area. So lateral area is going to be 1/2 times the perimeter of 24 times the slant height, which is 5. So 1/2 times 24 is 12 times 5, which is going to be 60. So our lateral area is going to be 60. Then our total area is going to be the lateral area plus the base area. Lateral area is 60 plus the base area 36. So our total area would be 96. Cone, same concept. Except with our cone, our base is always going to be a circle. So circumference, 2 pi r, instead of perimeter. So we have 1/2 circumference, 2 pi r, times the slant height. Well, this half and that 2 eliminate, so then our lateral area is going to be equal to pi times r times L. And of course, your base figure is going to be pi r squared. So once we know our radius, which we're going to say our radius is 3, and once we know our slant height, we'll just say that the slant height is 5, we can figure out the total surface area. So lateral area is going to be equal to pi times radius 3, lateral area 5. So that's 15 pi for the lateral area. Base area is going to be equal to pi times 3 squared, which is equal to 9 pi. So then total area is equal to the lateral area plus 1 of the base areas. So we got 15 pi plus 9 pi, which is 24 pi. So hopefully that clears a couple things up. I know that the height and the slant height are a little bit different type of terminology, but that's the main keys for these figures that have a vertex point for a pyramid and for a cone. Good luck. Have a good day.